Hi guys, today we're going to talk about the third type of factoring word problem that we're going to see in chapter 6. I'm calling this a formula problem because you're going to be given a formula that you use to solve this. You're going to notice that for this particular example, I'm going to go a little bit faster because at this point I feel like you should have some understanding of each of the 4 steps of solving a word problem, and you should have an understanding of how to factor and solve. So I'm not going to go into quite as much detail, and I'm going to be asking you guys to stop and pause the video several times so that you can work through some of this problem on your own, because I know you can. So let's get started. So this is here to give you a quick refresher on the 4 steps, the map that we use when solving word problems. This is the same map we will use to solve every word problem this semester, and I'm hoping at this point you feel pretty comfortable with it. So now I'd like you to just pause the video, take 1 to 2 minutes to read through each of these steps and sort of refresh your brain as to what you should be thinking as we work through this problem. So here's our problem. This is, again, I'm calling this a formulas problem. An arrow is shot into the air with an upward velocity of 48 feet per second from a hill 32 feet high. The height h in feet of the arrow after t seconds is given by h equals 32 plus 48 minus 16t squared. How many seconds later will the arrow be 64 feet above the ground? Okay, so we're on a hill, we're shooting an arrow. And the arrow is going to go up, 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 and then down and hit the ground, okay? So this is a formula word problem, and the big giveaway here is you are literally given a formula right inside the problem, okay? So when that happens, you should think to yourself, okay, this is a formula word problem, and it will generally be about some type of projectile motion, shooting an arrow or something falling, where you're dealing with height and time. So for formula word problems, here's what you really should take away from it. There's going to be 2 variables, okay? Here we have h and t, all right? You're going to plug in for one and solve for the other. Here the 2 variables are t for time and h for height. So we're going to plug in for the variable that we know and solve for the variable that we don't, all right? And we'll go into greater detail on this in the next few slides. Okay guys, this leads us into our first step of labeling. Now whenever we're at this step, we always read the problem 3 times. The first time we just read it. The second time we're going to circle important words and symbols. And for these problems, the things that I circle are the variables. So I see an h, I see a t, I know those are my 2 variables that I'm dealing with. It's a formula problem, so I know that I'm going to be plugging in for one of those variables and solving for the other, okay? And the really big part of these problems, the piece of information you're really going to want to zero in on as you work through them, is actually going to be found in the question, okay? The piece that you know and the piece that you're looking for. So I want to know how many seconds later will the arrow be 64 feet above the ground. That's the number I'm really going to zero in on, the one that I'm asked about in the question, okay? So when I do projectile motion problems, I like to draw a picture. It helps me work through it. I almost like make a little movie in my head, and it's really going to help me work through the problem, especially when I get to the last step. So here I just have a little picture. I would have sketched this right on my paper of a person. They're shooting the arrow. We know the arrow is going to go up, 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 and then it's going to reach a maximum height and start to come down. Okay, that's sort of, you know, what's happening in our problem. And when we shoot our arrow, we're like up on this hill, so it's going to have to come down and hit the ground somewhere down here. So I have my picture, I've circled the 2 variables, and I found that important bit of information that I'm going to need to use when I solve, which was located right in the question. So now I need to really think to myself, which variable do I know and which variable don't I know? I have my 2 variables, h for height, t for time. Which one of those do I know and which one don't I know, okay? Well, I know the height h. H equals 64 feet, right? So that's the one I'm going to plug in for. The variable that I know, I'm going to plug in that 64 to, right? And that's why I said to really zero in on the number you're given in the question. Because you know you want your arrow to be 64 feet above the ground. So I have a number I can plug in for h, which means The variable I don't know, okay, is of course t. I don't know time, right? And when you're thinking through these variables, right, you're asking which variable do I know? Well, I know h, and which variable don't I know? What's the problem asking me? Well, it's asking me to find how many seconds later. Seconds are a time. So I don't know t. I don't know the time. So that's the variable I'm going to be solving for. Okay? So now I can plug in for h and I can solve for t. Now it's just a matter of doing the algebra. So when I translate this from English sentences to math equations, well, I already have all of the information that I need to know, right? I know that the height is 64 feet. I don't know t, so I'm going to plug in 64 for the height, and I'm going to solve for t. So I just go back to my original equation formula that I'm given in the problem, right? And instead of writing h equals 32 plus 48t minus 16t squared, well, I know what the height is. It's 64. So I'm just going to put a 64 in there. And now I've got that one variable t that I can solve for. So whenever you're solving, you only ever want to be solving for one variable, right? That's so important. So now let's use algebra to solve. Okay, so now we can actually solve. We have that lovely equation that we generated when we did our translation step. So we're going to use algebra to solve our translation, right? And the first step of doing that is, of course, to set our equation equal to 0. We need to get this 64 over here. We know that when we're solving these types of polynomial equations, we need to set our equation equal to 0, factor, and solve using the principle of zero products. So I'm going to subtract 64 from both sides, which gives me 0 equals negative 16t squared plus 48t minus 32. Notice I rewrote this so that my variables were in descending order, okay? That way, in case I need to use the AC method, my A, B, and C will be lined up correctly. My coefficients will be in the right place, okay? Then you're going to factor. Now that you have your polynomial set equal to 0, right? The first question you should always ask yourself when you factor is there an overall GCF? Take a moment, pause the video, look at those coefficients and variables, and decide if there is. Why, yes, there is. It's negative 16. Because my A was negative, that negative has to come out with my GCF, right? So then you would factor out your GCF. Then I'm going to count how many terms I have. Take a minute, look at your paper, count the number of terms you have in your polynomial. That will determine which method you use. I have 3 terms. It's a trinomial, which means I need to use the AC method to factor and solve. So I'd now like you to pause the video, factor your trinomial. Then you're going to use the principle of zero products, which again says if I have two factors being multiplied together and they're equal to 0, one of those factors has to be 0. So now pause the video, look at your paper, and solve for t. And when you do that, you should get that t equals 1 and 2 seconds, which should sort of seem a little peculiar. Why did I get 2 answers here? You might know, or you might not know already. We'll talk about that on the next slide. So now it's time to interpret our answer, and this is such an important part of the process. When you do this, you want to go back to the original problem and think, what was the question asking me, and how does my answer make sense in context of this question? Well, here we were being asked, how many seconds later will the aerial be 64 feet above the ground? And that's really the key, is that 64 feet, okay? We arrived at the answer of, well, after 1 and 2 seconds, and we thought that was maybe a little peculiar. So let's think about what this question was even about. It was about us shooting an arrow up into the air. So let's look at our picture that we drew, and let's say that this is 64 feet, okay? This on our picture is where 64 feet would be. So our arrow is going to go up, and it's going to hit 64 feet right here. But then it's going to continue to go up and reach its maximum height, and then the arrow has to come down. And you guys, on the way down, look, it hits 64 feet again, right? So it hits 64 feet on the way up and on the way down. And that's why we arrived at 2 answers, okay? So we need to make sure, I like to write my answers to these in a sentence. We want to write and mark our answer very clearly. So I wrote the arrow will be at 64 feet above the ground at 1 and 2 seconds, and always circle it for me, okay? So remember, when you're doing these word problems, use that 4-step map of label, translate, solve, and answer. I hope you're starting to get pretty comfortable with this at this point. If you have any questions as you work through your homework, remember to post in the questions forum. Good luck, and I know you can do it.